On today's video lesson, we'll be looking at variable charge cations and how we name these cations while they're inside of ionic compounds. So how we name ionic compounds is going to change a little bit because now we're dealing with ions that have more than one charge. And we give those ions the name of variable charge cations. And a good example of how we name something is going to be a little different. In the past, we look at, just a quick intro here, this would be called copper oxide. And I'm just letting you know, today we're going to change how we name these when I deal with cations that have more than one charge. Now, in the past, we've seen this periodic table, and I've said what are the charges on top of these groups. Group 1 had a 1 plus charge, 2 plus, 3 plus, 3 minus, 2 minus, 1 minus, and 0. And so I think we're pretty proficient now at identifying what the charges are. On top here, these were the number of valence electrons that are inside or on my outer shell of my electrons, and we went all the way up to 8. And just to clarify, something has 7 valence electrons will need 1 more electron, therefore it becomes a 1 minus charge. And likewise, something that has 6 outer shell electrons will need 2 more electrons, getting a 2 minus charge, just so we're clear on that point. So the question becomes, we've never dealt with the middle of the periodic table. How do we deal with these atoms? I have been avoiding them until now, and I've been avoiding them because these atoms have more than one charge, and they are known as variable charged cations. So anything under the staircase here, too, and inside of my whole entire D block, they have more than one charge, these atoms, and therefore they are known as variable charged cations. An example of a variable charge cation would be something like copper. Copper has a 1 plus charge, but it could also have a 2 plus charge. So variable meaning more than one charge, all right? So it's a cation that could have different charges. So we can't just say copper is a 2 plus because it might not be. It might be a 1 plus. Same way with lead. Lead could be a 2 plus or a 4 plus. So because they have more than one charge, it's going to have different rules of when we use them in naming ionic compounds. Just traditionally, how have we named this in the past? We have called this sodium and oxygen combined together to form sodium oxide. And we just drop the end of oxygen, the suffix gets dropped, and we add IDE to it. And the next problem, let's check it out. This is Mg, and this should be an F2. Now MgF2 has a name, magnesium fluorine. But fluorine gets changed to fluoride, it becomes magnesium fluoride. Now these are my traditional ways to name ionic compounds. The metal always comes first, followed by the nonmetal second, and the nonmetal always has an IDE ending. Here's another good example. Li3N, once again the metal is named first, followed by the nonmetal, and the nonmetal is going to have that IDE ending. Lithium nitride. Here's where we're going to change something up now. Copper oxide is how this is traditionally named. But what we're going to add here now is going to be a charge. We're going to put the charge, whatever charge copper has, 1 plus, 2 plus, 3 plus, 4 plus, we're going to put that inside our parentheses. So when we name copper oxide, we now have to write down its charge. We have to write down its charge because we don't know which copper we're dealing with. There's a +1, a +2, +3, etc. And because we don't know that, we have to identify it. You're going to identify it eventually with Roman numerals. 1, 2, 3, and all of these will go inside our parentheses here. Okay, now we're going to be responsible for naming these. I'm going to let you know copper has more than one charge. So therefore, when I name it, it's not just going to be copper oxide. I'm going to be responsible for throwing some parentheses inside here. And inside those parentheses, I'm going to have to put a charge. Maybe it's going to be a Roman numeral 1. Maybe it's going to be a Roman numeral 2. So let's go about figuring out how to determine the charge on copper. Because that's really what the question is. What is the charge on copper? It has more than one charge. I'm going to give you the formula. The formula is I have 1 copper and 2 oxygens. And one of the truths, one of the principles of ionic compounds is that when I add up all the cation charges and all the anion charges, it must equal 0. Well, here's a given. You know from the periodic table that copper has a 2 minus charge. And so therefore you have 2 copper, you have 2 oxygens now. That's what this number here is. I have 2 oxygens. Each oxygen has a 2 minus charge. So what I know is this. Oxygen altogether, 2 minus plus 2 minus, has a 4 minus charge. I'm going to tell you a little secret here, and that is that oxygen has a 4 minus charge. Copper needs to have the opposite charge. Whenever there's not a subscript written, it's going to be 1. So that means there is 1 atom of copper. That atom of copper must total the negative charge. I must cancel it out with the 4 plus charge. So what is the charge for copper? 4 plus. So how do I write this finally? I finally write this as copper, parentheses, in Roman numerals, 4 oxide. And that tells me that copper has a 4 plus charge. Another way to look at the same problem is going to be, take the given. The given is the formula, CuO2. I have 1 copper. And you could almost think of it as a math problem. I have a 2 minus, oxygen, that's a given, it's from the periodic table. I'm going to multiply that by 2 to get a 4 minus charge. I've already said they need to be even. The pluses and the negatives must be equal. Well, just like 2 times 2 gave me a 4 minus, I think the question becomes, what charge times 1 gives me a 4 plus? And when you look at it that way, the charge up here must be a 4 positive. And that 4 positive is what I'm going to put into my parentheses when I name copper 4 oxide. Alright guys, let's check out this problem here. And this problem, I have 1 gold and 1 phosphorus. And I'm going to name this gold phosphide. The only thing is that I do need some parentheses on the inside here, and I'm going to put a Roman numeral inside here. So let's figure out what the charge on gold is. I have 1 of each because they don't have subscripts. Phosphorus has a 3 minus charge, and I have 1 of them. Therefore, the total charge on phosphorus is 3 minus. The total charge on the gold side needs to be 3 plus. They need to be opposite. They need to be equal and opposite. So therefore, the question is, just like 3 times 1 gave me a 3 minus, what times 1 is going to give me a 3 plus? And the answer to the charge is going to be 3 positive. So I will name this gold 3 phosphide. Okay, this one, the formula is NiP. It's going to be nickel phosphide, and again, we're going to key in on this. What is the charge on nickel? Nickel has more than 1 charge. It's located in the D block of the periodic table, so let's calculate it out. Phosphorus has a 3 minus charge, and right now, without a subscript, I know there's 1 of them. 3 times my 1 gives me a 3 minus total charge for my anions. Same way, over here, I need 3 plus. All right, what times 1 is going to give me a 3 plus? And once again, the answer here is 3. And so nickel is a nickel 3 phosphide. And we're going to stop the lesson right here, guys. That's pretty much how it's done. I hope it helped you. Have a good day.